Robotics has changed a lot over the past few years, not only because of advances in technology, but also in how and where robotics is used. The difference is that instead of large corporations and government agencies doing robotics, now hobbyists and youth can do their own projects, and in turn develop useful solutions to problems large organizations can sometimes overlook. A major reason this change has happened is called the open source movement. Before we delve into robotics, let's take a look at what open source is. There are many internet browsers, but the main three are Microsoft Internet Explorer, Mozilla Firefox, and Google Chrome. Firefox and Chrome are both great, but Internet Explorer, abbreviated IE, is sometimes referred to as the best browser to download other browsers with. IE is an example of non-open source software, being unmodifiable, not available for free, and controlled by Microsoft, its developer. In short, if you don't like IE, there's no way to change it, besides begging Microsoft to change it. Firefox is completely free, and you can download the raw code and change it to fit your purposes. Chrome is partially open source, Google having released much of its code as the Chromium project. Incidentally, both browsers work well, and both users and companies gain from them. Google can take the changes made to the Chromium browser project and implement them in the next release of Chrome. Firefox users can install plugins, an attachable modification to Firefox that changes how it works, so it can block web ads, stop viruses, etc. Now, this is great for software, but what does this have to do with robots? Let's say you're an entrepreneur, and you want to sell a robot that, say, waters your lawn on a schedule. You build a physical robot, custom making every part, then you code it. You start to sell it, and your sales aren't that good, since the robot wasn't well built and the code was not the best. Now, what if you release your plans for the physical robot and its code for free on the internet? Some robotics engineer or WizKid sees your design issues, figures out your code errors, and fixes them. He or she then releases them as their own modification to your design. You see this and implement the changes on your next batch of robots. You benefit from increased sales, and the person who made the changes gets credit, which might help him or her get a job someday. Some other internet user can try to build a robot of his own from your plans, and he benefits. This model is what open source is all about. There are hundreds of projects following this format, and this is what makes it easy for a hobbyist to get involved with robotics. I myself have had an experience with open robotics during the spring of 2012. As part of the 4-H Science Ambassador Project, I was invited to demonstrate an innovative solution to a real-world issue at 4-H's booth at the 2012 USA Science Engineering Festival, USASEF, in Washington, D.C. At the time, the Fukushima Daiichi nuclear disaster was still in the news, so I decided to solve an issue that plagued disaster cleanup workers, the lack of widely available robots for radiation detection. My goal was to design a robot that was cheap, easy to build, easy to operate, and could detect dangerous levels of radiation. Open robotics was invaluable. For example, I posted a control scheme that was based on an open source project where someone hacked the closed source Wii Nunchuck. Their code was poorly written, so I fixed it and posted it on GitHub, an open source repository website. My robot used a piece of open hardware called an Arduino microcontroller, basically a simple computer that I used as the brain of the robot. Arduinos are open source, and if you have the parts to build them, you can make one yourself, but I used an official Arduino Uno board, the newest model. I made 3D models of the robot, and I also released them. Basically, any file or data I produced, I posted to the internet. Now, if you know what to look for, you can build one of these robots for yourself. The USASEF trip was great, and I experienced much at the festival, and also the other things in D.C., like the Smithsonian museums, memorials, and I actually got to see the Bill of Rights and the Constitution. I also got to demonstrate my robot to the local hackerspace, Hack DC. This is all made possible by the 4-H Science Ambassador Program. But back to the purpose of my project. This design could be advertised and promoted, and my relatively good project could be tweaked and modified to perfection, so when another disaster happens, simple, hand-built hazard detectors will be on the scene. This brings me to another point. Open source is unbiased and great for emergencies. Say you're from a third world nation, and you just got a laptop and an internet connection. You won't be able to afford expensive commercial applications, so Adobe Photoshop isn't an option to make a poster for your community. GIMP, however, is a great open source photo editor, with lots of tutorials how to use it. This gives people all around the world access to a photo editor. But let's take a more extreme example. A flash flood hits your town's water purification facility, swamping it with dirty water. It'll take weeks to purify the system again, and meanwhile you'll run out of drinking water. If someone released open plans to create a water purification device, you could build it and have safe, potable water. If someone sells plans to make a purifier, and it costs $50 for the plans, you'll have to buy them, and some of the financially disadvantaged in your community will have to find some other way of procuring water. Notice that this all requires internet access. The internet is key to making open source work. It costs me nothing to copy a file, and only a tiny fraction of bandwidth time to send it, so releasing open source data is practically free. It only takes your time, which most people seem to have an abundance of. And, as Senator Ted Stevens once said, the internet is a series of tubes, not a big truck. It's also an ideal way to transfer and share information easily and exactly. Back in the 70s and 80s, many simple programs could be hand transferred from a book onto your computer. Floppy disks and later CDs were even more useful and made it easy to transfer large amounts of data precisely. Then in the 90s, it all changed with the World Wide Web, which brought networking to the common computer user, although Usenet had been around for longer. Now the internet is so widely used that pretty much all hobbyists and DIYers use it to share information. For tech hobbyists, this is invaluable, especially in robotics and computers. Cryptographers will post their encryption programs so others can test them. Certain YouTube commenters seem to have amazing grammar. And for roboticists, nothing works better than to solve an issue than ask about it on a robotics forum. Basically, if you use the internet right, you can have a huge team of experts at your service. Again, this is what makes open source work. The conclusion: open source helps everyone, including companies, engineers, hobbyists, and even average people.